that we still have no shipment of our drones. I'm starting to think I should just go down to Walmart and buy some remote control helicopters or something. But I will go back to the purchasing department right after this and see what they can do for us and figure out where these things are at. Hopefully, I can't really imagine this project going anywhere if they don't come by the end of this week. It just seems too late. By the end of this week, we're getting close to, let's see, today's the 14th, so next week is Thanksgiving, so goodness, it's come so fast. So if we don't have the drones by the end of this week, we're going to have to switch our final project to something else. I'm not sure what that will be. Excuse me. My final project before the drone idea was an extension on the hydraulic arm project, which I suppose we could do and just feel kind of like going backwards in time. But another option that we might have is to do a project from another source that I have. So I'm going to present another possible project right now, and I'm going to have you guys do something new that you've not done before, and that is to prepare a proposal for your solution for such a project. And when you're done with that proposal, you will return it to me, and then that will become our project if this other project fails. So this is the project that I'm going to try to do right now. I'm trying to develop what is called a capacitive hygrometer. And if we look here on Google, you can see that capacitive hygrometers you can buy here for $159, $68.97, $80, $180, $135. But most of these hygrometers are designed for just, what a hygrometer is, first of all, is it measures humidity or water content in something. And particularly, I want to measure water content in soil. So if I go to a capacitive soil hygrometer here, changes things a little bit. Here's a Adafruit capacitive touch hygrometer. I'm not sure what that actually is. But here we have some different soil moisture sensors. Here's one for $20 all the way down to $7. And here's one for $95, $754. This is actually more of the type that you would see usually, closer to $1,000, but they do make them pretty cheap. Like here's one for $1.79, but this one is actually not a capacitive soil hygrometer. This one is what is called a resistive soil hygrometer. And the way this works is you have this little fork that you stick in the ground here, and you pump some electricity through it, and the electricity goes through the dirt from one probe to the other. And if there's more water in the ground, then the electricity goes through easier because the resistance is lower when there's more water. And so you get more current when there's more water and less current when there's less water. There's a couple of problems with this. First of all, we want to make a soil hygrometer that uses very little energy, very little electricity, and you have to pump electricity through it. That uses a lot of electricity, so that's not something we want. Second of all, when you pump electricity through something and there's water nearby and salt and other electrolytes, it has a tendency to corrode metals. And the metal that is coating this fork here will get corroded, and then this thing won't work very well anymore. You'd constantly be having to adjust it or clean it or replace it, and we don't like that idea. We want to have something we can just bury in the ground and leave it there for months or even years at a time. And so we're thinking a capacitive hygrometer is the way to go, because the way a capacitive hygrometer works is that you have a capacitor that has a voltage across it, but there's no electricity flowing. It's just a voltage on it. It's charged up, but no electricity is flowing. So it uses very little energy. But when you put it in the presence of soil, the amount of charge on it will change. It will either increase or decrease depending on the water content of the soil. And that can tell you how much water is in the soil without having any real, appreciative flow of energy or electricity. The problem is that these are not designed to be buried either, usually. Usually these are designed to just be inserted in the soil and pulled out, and usually they're quite expensive in many cases. Also, we'd like to be able to do this at different depths. We'd like to choose the depth that we're interested in for a specific area. Some places we'd like deeper measurements, some places we'd like less deep measurements. And so you can see here that there are some of these things out there, but not necessarily that was something we're looking for, because the prices are still too high. I'd like to find something that's in the price range of a couple of dollars so I can make several hundred of these things and not spend more than a couple $1,000. And so here is, let me see if I can find you, here's a good diagram of what we're looking for. So what we've got here is we've got two terminals, one on each side, and then we have these metal electrodes, which are these black things, which are close to each other but not touching each other. And this creates a capacitor essentially, that is going to be able to sense humidity. There's a better picture of it. There should be a picture of one here somewhere, an actual photograph. I'm not seeing one, however. Well, I do happen to know where there is one. So let's go eBay. Oh, nice, Barbie. So here on eBay, I have found this right here. This is exactly what I'm looking for. A capacitive hygrometer where you have these different electrodes that are really close together, and there's an electric field between the electrodes as you charge up both sides of this capacitor. And then you can go ahead and measure humidity changes. As the humidity changes around this, the electric field changes depending on the amount of water in the air, and then you can determine how much water is in the air. This is designed for air though. If you put this in the ground, you will have the same problem as you did with the other one, and that is that you will get conductivity. The electricity and the charge will jump from one of these electrodes to the other electrode, and you'll get electricity, going through the water and the soil, and then you're driving electricity and you're losing energy, and also it will corrode and it won't work. So, what do we do? Well, this particular type of hygrometer will still work even if it doesn't touch the soil. In fact, it will work, period. If this actually touches the water, touches water in any way, it will not work. So we need to actually protect this. We need to cover it. The problem is that it needs to be completely airtight, watertight. It needs to be resistant to a little bit of abrasion damage because it's going to be underground. And it needs to be resistant to freezing, to getting too cold in the wintertime. And also it needs to be able to come up to the top of the soil with a safe, with some kind of something that's going to keep it safe. So, well, come up to the top of the soil is not a good way to say it. It needs to be, the wire that is connected to it, this wire that is included with this on this eBay listing, needs to come to the surface of the soil, needs to be available at different lengths, and this little circuit board here also needs to be on the surface of the soil at the ground level, but it needs to also be safe. And so this is what your job is going to be. This is the humidity hygrometer that I'm going to buy on eBay. And I might just buy these now because they will come. They will come even if the helicopter stuff won't come. But anyway, your job is going to be for the next, until we get our drones, unless we don't get our drones at all, but until we decide on what we're going to do for our final project, this may become our final project. Your job is going to be to figure out a way to make this device soil-proof, waterproof, and this chip that's going to be on the surface also soil-proof, waterproof, crush-proof, and also make sure that it's easily visible, that maybe it's off the ground a little bit, but in such a way that we can do this so that the entire device costs less than 10 bucks. You can see here on eBay that this device costs $1 in United States dollars, costs about $2. So you have about $8 to play with to make this device, to be able to have this device buried at different depths, protecting the device, protecting the cord as it comes up from the device to the ground level, and also this little microchip thing that's at the top to be protected in a weatherproof, waterproof, dirtproof, crush-proof kind of enclosure at the top of the soil that is also very visible, easy to access, and otherwise. Now, you're going to need materials. You're going to need specific materials when you make this presentation. When you come back to me, you should be able to say, this is what I'm going to do to this device, and these are the materials and the parts and the things that I'm going to use to do it. Not just, I have this idea that I drew out on a piece of paper and maybe I'll be able to find the stuff to do it, maybe I won't. But I actually want you to research the materials out there that are available for you to do this project. So I want you to get on to different supply stores or different whatever. You can search Google products or whatever. Places that I would recommend for searching things like this, would be hardware stores, online hardware stores. My favorite online hardware store is actually called McMaster Car. Let me show you what it is here. McMaster Car. It's kind of like the engineer's hardware store. And you can search things by product type, or you can just search up here. So for example, let's say that we're looking for some kind of a coating to coat this thing with, to protect it with, and I can just go coating, I can search for coating. And it has paints and coatings, anti-slip coatings, water repellent, restorers for tarps, concrete, asphalt maintenance, roof repair patches and coatings, wall and ceiling maintenance, tile, grout repair. You know, it has all these different coatings that are available. And so you could choose one. We might choose water repellent restorers or paint and coatings or whatever. And then it gives you lots of different types of things to choose from. You have rubber coatings. That sounds good. Let's look at rubber coatings. Now the great thing about this website is it does more than just show you the products. It will tell you all of the things, all of the qualities of the products, the different things that they do well. For example, it'll tell you the maximum temperature that this coating can handle. It will tell you also how long it takes for it to dry. It will tell you what kind of things that it's good for. It resists chemicals, salt, extreme temperatures, used on fabric, plastic, rope, and wire, right? So this website is extremely useful, and there are others out there like this. I personally like this one best, McMaster Carp. But there are others out there. I think Engr is a similar one. If you go to Engr Industrial Supply, they have a very similar kind of website that you can search things through. So there are lots of online websites for hardware supplies and industrial supply kinds of things. But in the end, you should have a design that you have mocked up, drawn up on some graph paper, or actually I would like you to go ahead and use SketchUp to do this drawing. So I want you to do your model in SketchUp this week, and then I want you to actually choose parts and supplies and materials and everything else for everything in your design, so that you know everything that you need to buy and how much of it you need to buy and how much it's going to cost and what the properties are for your proposal. Now, when you turn in your proposal, it will include everything. So if we are back here in McMaster Carp and we're looking for, let's say we're going to protect the wire with some kind of tube. So we're looking at tubing and we think, plastic tubing for fabrication, that looks good. I'm going to look at plastic tubing for fabrication, and I'm going to look at wear-resistant nylon. That sounds good because I want something that's going to be resistant to being worn out. And I look at these tubes and I can see outer diameter and inner diameter here. And I'm thinking the inner diameter needs to be maybe 1/2 inch. So this is the one I'm getting here. And I open this one up and it's 5 feet long, and so maybe I can make 3 or 4 out of this thing, but I'm going to use this particular one. I want to get the product detail for this, first of all, and I want this information to be printed off and inside of I want all this information inside of my proposal. These are $14.20 each. That means if I use 1 foot for each design or for each product, then I divide that by 5 to get my price for this tube that I'm using in that design. Okay? So it's up to you how you design your thing and what materials you're going to use, but every single material you use, I want a page that shows us all of the details of that product, from price to physical details to everything else. And then if you need to make notes on it saying I'm only going to use 1/5 of this for each one of these, then make notes like that as well. In the end, your proposal should include a complete design with a 3-dimensional drawing of the design that is labeled, and all of its parts are labeled, and all the parts have products that they're associated with that you've researched out that you're going to use to make that part. And this is what I would expect, I think, of this week. I'd expect all of these pages for all these materials and parts. I would expect a drawing of this design with completely labeled with all the parts and what they're going to do and everything else. And also a breakdown of the total price for your design. So this part has this, it costs this much, this part costs this much, total is this much for the total design. And that is what we're going to do here while we're waiting to see if our drones come in. Now, if our drones don't come in this week, then when we get back from Thanksgiving, what we will start doing is we will start prototyping this design that you have just designed. And I will buy all the parts, I will send them to you as quickly as I can, and you guys will start building these things. And essentially that's, if you guys will turn these in to me by this Friday, and if our drones don't come in that Friday, I'll go ahead and order those parts that Friday, and I'll hopefully have them mailed to you over Thanksgiving break So that when we get back together, you've got parts and you're ready to start prototyping and testing and building. Okay? Now this is a real project. This actually has a real client. This is a project that I'm doing as I do research out at the UNL farm here in North Platte. So on Wednesday when we meet, we will meet on Wednesday and we'll meet on Friday, but if you have any questions for me, that's the time to ask them. So while you're designing, if you come up with a question that you need clarification on, or something that you thought of that you would like to share and get some feedback on, that's the time to do it. Engineers are always meeting with clients to clarify things, to present their ideas, to get feedback, to ask questions, and that's how we're going to treat this week. Is our class meeting times will be client meeting times. And of course, if you need to email me any questions, you may do that as well. Do you have any questions before we break for today to let you get started on this? I will send this to you as well. I will email this particular eBay page to everybody so they can all see what this thing is. And I will also send you a video. Well, I will see if I can find a video. I think there is a video out there, but anyway, I will at least send you this eBay page so that you can see what this part is, because this will probably be the part that we use. And then we will go from there. So the larger piece needs to be completely waterproof along with and protected. But it can't be enclosed inside of a box with air in it. So it needs to be waterproofed in such a way that it's got a material that's coating it somehow. If you put it in a box with air in it, then it won't be measuring the humidity of the soil. It won't be measuring the soil's moisture content. It will be measuring the humidity inside the box that it's in. Okay? So it needs to be as close to the soil as possible without ever touching it. Does that make sense? However, this other smaller piece, this smaller rectangular piece, that piece is essentially a little computer chip board. It has some electronic components on it. Those will get ruined if they get wet. So they can be enclosed in a box, but they also need to be accessible. We need to be able to open that box, and that you can see on the top there's a little blue box that has a little screw on top of it. That screw needs to be adjusted from time to time, and so we need to have access to that box if possible. And then the cable that goes between the two rectangles, that cable also needs to be protected. So it's got a rubber coating on it already, but it would be better if it had another coating or some kind of sleeve or something to prevent it from getting damaged in some way. You don't want somebody coming along with a shovel and cutting through it, for example. And also you can see that it's connected. These things are connected by these little plugs. And those plugs need to be reinforced a little bit. We need to be able to plug them in and then coat them and protect them, and so they don't come unplugged, and so there's no way that water can leak in from anywhere. That would be the ideal situation. Okay? Yeah, so I would say that we probably want to be able to bury it anywhere between 6 inches and 2 feet, maybe. Anywhere between 6 inches and 24 inches depth. That would be a good range to be able to bury it. And we want to be able to take any sensor that we have. Let's say we have 200 of these things, and take 100 of them just randomly and bury them all at 6 inches, and have enough cord to bury them deeper if we need to. So that would require us to have this cord here be a particular length, you know, the 2 feet length or 3 foot length. But that's easy to do. That's not hard to do. It's a very simple electrical cord. So, any other questions? Okay. If you have any more questions, we will meet again Wednesday. So write them down for then, or send me an email between now and then, or something else. And go ahead and get started on this project. Remember that you're starting off by doing a little bit of research on this thing, starting to draw a picture, starting to draw some designs, get some ideas put forward, figure some out. You might consider drawing up 2 or 3 designs and picking the best one, like we've done in the past. But in the end, what we're looking for is a proposal. You know, it's a proposal is essentially like a portfolio of information that shows your design and all the stuff that goes with your design, so that you present it to a client and say, you want me to be your engineer because I can do a great job with this design. Okay? We'll talk more about this on Wednesday, and we'll see you then.